All right, let's get right into it. Quantum mechanics. Kind of a dense topic, maybe even a little intimidating, but trust me, fascinating stuff.
Yeah, definitely.
We're going to be talking about a world where, like, things can be in two places at once, spooky action across the universe. The really juicy bits of quantum mechanics. We've got a pretty good stack of sources here.
Oh, yeah.
It's like our portal into the subatomic world. And you know what's amazing to me? It's not all just, like, theory, right?
Yeah.
This stuff actually underpins a lot of the technology that we use every single day.
Right. I mean, if you think about all the things we take for granted, lasers, transistors, things like that, all of that is based on quantum mechanics.
Absolutely. It's like this hidden world that's operating beneath the surface, making all this stuff possible. And we're going to try to unpack all of it. So where do we even begin?
Well, I think a good place to start is with just a basic definition. What is quantum mechanics?
Okay, so quantum mechanics 101. What is it?
So, in a nutshell, quantum mechanics is the set of rules that govern the universe at its smallest scales.
Okay.
We're talking about the behavior of atoms and the particles within them, really, really tiny stuff.
So subatomic level. Got it. But how is that different from the physics that, most of us learned in high school? Like, what makes it so special?
Well, in our everyday world, we kind of assume that things can have any amount of energy, right?
Yeah.
But quantum mechanics throws a wrench in that and says, nope, energy is actually quantized.
Quantized. What does that even mean?
It means that it can only exist in these discrete little packets, almost like tiny bundles of energy.
So not a dimmer switch, but more like an on-off switch.
Yeah, it's more like a light switch, a series of steps rather than a smooth continuum.
Huh. Okay.
Yeah.
I never thought of it that way. But, who was the first person to figure this out?
Well, that would be a physicist by the name of Max Planck.
Planck. Okay.
Yeah. Back in the early 1900s, he was studying something called black body radiation, basically how hot objects glow.
Okay.
And he found that classical physics just couldn't explain the pattern of the light that they emitted.
So he was stumped.
Exactly. And his solution was to propose this radical idea that energy isn't continuous, but comes in these little bundles, these quanta.
So he basically just said, what if energy is not a smooth flow? What if it's like a bunch of little Lego bricks?
Exactly. And surprisingly, it fit the data perfectly. His idea revolutionized physics.
That's wild. It's so simple but so powerful. It's like a key that unlocked a whole new understanding of the universe. But how did we get from, energy packets to light acting like a particle? Because, that's just bizarre.
Yeah. Well, a few years after Planck, another brilliant physicist, this time Albert Einstein, came along and took Planck's idea and sort of ran with it.
Right. Einstein, of course.
He used it to explain something called the photoelectric effect. It's basically how shining light on certain materials can knock electrons loose.
Right. I remember that from, like, high school physics. And that was a big deal because it suggested that light wasn't just a wave but also a particle, right?
Yeah, it was a huge paradigm shift. All of a sudden, light had this, split personality, right?
Yeah.
Sometimes it behaves like a wave, and sometimes it acts like a particle. And that right there, that is what we call wave-particle duality. It's one of the most fundamental concepts in quantum mechanics.
So light's this kind of like Dr. Jekyll, Mr. Hyde kind of thing.
Yeah.
But does that mean that, like, everything is both a wave and a particle?
Well, it's most noticeable at the subatomic level. So electrons, photons, but in theory, yeah, even macroscopic objects like, my coffee mug.
Okay, hold on. So you're telling me that this coffee mug has, like, a wave nature to it?
In principle, yes. But the wavelengths are so incredibly tiny, we just don't see them in our everyday lives.
Okay, so everything's a little bit wavy.
Yeah.
But is there any way to actually, like, prove this?
Oh, yeah, for sure. There are tons of experiments that demonstrate this. The most famous one is probably the double-slit experiment.
The double-slit experiment. Yeah, I've heard of that. But I don't really understand it.
Okay, so imagine you have, a beam of light, and you shine it through two narrow slits onto a screen. What would you expect to see on the screen?
Well, if light's a wave, I guess you'd see two bright spots, right? Like one for each slit.
Exactly. That's what classical physics would predict. But that's not what happens. Instead, you see what's called an interference pattern.
Interference pattern. What does that mean?
So instead of just two bright spots, you get a series of bright and dark bands, like, ripples in a pond.
So the light's going through these two slits, but it's creating this wave-like pattern.
Exactly. It's as if each particle of light is somehow going through both slits at the same time and interfering with itself.
Wait a minute. So a single particle can be in two places at once?
That's the weirdness of quantum mechanics. It's called superposition, and it's one of the things that makes it so different from classical physics.
Okay, I think I need a minute to process this. A particle being in multiple places at once. This is already blowing my mind.
Yeah.
And we've only just scratched the surface.
That's right. And to make it even weirder, if you try to actually measure which slit the particle goes through, the interference pattern disappears. It's like the act of observation forces the particle to choose a path.
So it's like, until you look at it, it's doing both. And then, boom, it's got to pick a side. That's crazy.
It is. It's like our consciousness is somehow influencing the behavior of these particles. It's a mystery that has puzzled physicists for decades.
Okay, we got to dive deeper into that. But before we get too far down that rabbit hole, there's something else I'm curious about.
Yeah.
The Heisenberg uncertainty principle.
Ah, yes. Heisenberg. One of the cornerstones of quantum mechanics.
I remember hearing about this back in school. Something about not being able to know both the position and the momentum of a particle with perfect accuracy. Is that right?
That's the gist of it, yeah. It basically states that there's a fundamental limit to how precisely we can know certain pairs of properties of a particle.
Okay, so you can't know both where it is and how fast it's going at the same time.
Precisely. The more accurately you measure one, the less certain you are about the other. It's like a cosmic trade-off.
So it's not just like a limitation of our measuring tools, it's a fundamental rule of the universe.
Exactly. It's baked into the fabric of reality at the quantum level.
Wow. So if you know where it is, you can't know how fast it's moving. And if you know how fast it's moving, you can't know where it is.
It's more nuanced than that. It's not that we can't know, but that the particle doesn't even have definite values for both properties at the same time. It's almost as if the act of measuring one forces the other to become fuzzy.
So it's like, until you measure it, it's sort of spread out like a wave. But when you try to pinpoint its position, you lose information about its momentum.
Exactly. And that brings us back to the wave-particle duality. If something is spread out like a wave, how can it have a precise location?
Okay, now my brain is officially starting to hurt. We've got particles acting like waves, uncertainty about their properties, and the act of observing somehow changing things. What else can quantum mechanics throw at us?
Oh, there's plenty more where that came from. For instance, have you ever heard of quantum tunneling?
Quantum tunneling.
Yeah.
Does that have anything to do with digging tunnels? Because, I mean, we are talking about tiny particles here.
Not quite digging, but it does involve particles doing something that seems